Hi there, this is Math 7 Unit 6 Lesson 1, our CUSD homework packet here. Okay, and so like the last unit, and some of you may be new to watching these here, I don't answer the first one completely, but I'll read it through with you. For those of you who just want a little clarification there, because this is one that's a review of the lesson, so you want to make sure you can do that on your own. It says a movie theater sells popcorn in bags of different sizes. The table shows the volume of popcorn and the price of the bag. So we can see here volume in this section and the price of the bag there. It says if the theater wanted to offer a 60-ounce bag of popcorn, what would be a good price? Now notice it says if they did, what would be a good price? It's not asking for an exact price. It wants to know what would be a good price. So if we were to add to our table here another row, if we're saying if I had 60, the question is what would be a good price for a 60 ounces of popcorn. Okay, so as you look for this, you want to try to figure out, is there some sort of relationship between these quantities? I mean, that's the topic of today's lesson. And so when you look at the first one, you can see, for example, that the price of a bag is $6 for 10 ounces, right? So if you think about how much does that cost for, dollar per ounce, which is how you would usually figure that out, this is costing you $6 for 10 ounces, which means that basically it comes out to be about 0.60, right? So if you were to kind of write that as a decimal. When you look at the next one, you have 8 out of 20, which again is a decimal, is 0.40. So we have a decrease here in how much that's going to be costing us the price per ounce. This is 60 cents per ounce. This is 40 cents per ounce. So we can see that the more popcorn you buy, the less your cost per ounce is actually going to be. So by the time you get to 60, it should be even less potentially. But again, this is a question asking about if they wanted to, what would be a good price? So you need to use some logic here to figure out what might be a good price based upon the trend that you see here, right? Because these are different, we know it's not proportional. It's not going to be a straight line that says, you're going to always have this much and that's going to be a straight line. It's not proportional, so there's going to be a difference. So give it some thought. All right, moving on to the homework part. Here we go. Number 2. It says, suppose you share a birthday with your cousin, but he is 4 years older than you. All right, so you have your cousin. That will make him C. Okay, there's your cousin. And his age is equal to your age. We'll make it Y for you plus 4 years, right? He's going to be 4 years more than you are. So here's you and 4. That equals your cousin. When you were 2, he was 6. Well, does that work there? If he was 6 and you're 2, and you're 4 years, and he's 4 years older, 2 plus 4 is 6, that seems to work. When you were 10, here's you for 10, he was 14. Well, 10 plus what gets you to 14? That's that 4 again. It says to write an expression for this relationship. Use A to represent your age at any time. Okay, so what do we know? Now, expression means it doesn't have an equal sign. So there's no equal sign. Okay, so keep that in mind. So all we need to know is that it's the cousin's age is going to be your age plus 4. That is the expression that we come up with. That's what we had up here, and that's what we proved to be true there as well. Okay, that's it. Okay, number 3, it says a bottle holds 16 ounces of water. It has X ounces of water in it. What would 16 minus X represent in this situation? Okay, so it has 16 ounces of water, and 16 minus X, now X is the water that it has in it right now. Okay, so this is what it has inside of it. This is what it started with, which means that if I was to subtract that, what would I be finding out? I might be finding out in this case, how much did I drink, right? How much I drank. That's what I'm probably finding out there. So that's what I'd be finding out. If I wanted to know how much water did I drink, if I have that much left in it, that's what I'm finding out. So that's something to think about there. All right, number 4. which expression is equivalent, so going to be the same as 30x minus 12y. Alright, so we have 4 different ones here where they want you to look at the distributive property to see what happens if you distribute the 3 through there, 6 through there, 3 through there, and x through there. Can you still come up with this expression? On the first one, the first thing I notice here is that I have a plus sign between. So while I can get a 30x there, and I can get a 12y there, this is a plus 12y, and I'm looking for a minus, so that's not going to work. On this side, I could do the distributive. I can do 6 times 5 is 30x, that's great. But then when I go here, I do 6 times 12, well, I'm trying to get to 12, so that's not going to work. Over here, I have 3 times 10, that's the 30x, that's great. And then 3 times negative 4, which is negative 12y, that seems to work pretty well. Let's check the last one. X times 30, sure, that's 30x. But then x times negative 12y, that becomes negative 12xy. You have to put the x over there as well, so that is also not going to work. So just choice C is the best one for this problem here. Alright, looking at the last couple here. Again, these are a lot of review ones from previous lessons. It says write an equation to represent the situation and define the variables. Okay, so the first one, we have 2/5 of the 7th grade students played in a sport at school. So we have a couple things here. We have 2/5, and we have the 7th grade students, and then we also have played in a sport. Played in a sport. Those are our 3 kind of elements here. Alright, so in our case here, we know that we have 2/5 of the 7th grade. So, I mean, variable could be S for students. So 2/5 of the students play what? How many of those are going to play a sport? Well, 2/5 of students play a sport, and we can do X for sport. So S equals the 7th grade students, and X equals plays a sport. Something like that. Okay? Go ahead and do number 6 on your own there. And finally, number 7, we have some different equations they want you to solve. Again, we can look here. To solve this one, you're going to multiply both sides by the reciprocal. So multiply both sides by reciprocal to solve that one. Over here, to keep the equation balanced, we're going to subtract 1.27 from both sides to find out what x is going to be equal to. This is a fun one here because, again, this is x divided by 6. So I could multiply by the, I think about it multiplying by the reciprocal, because what's the reciprocal of divided by 6? Well, that's going to be multiplied by 6, or 6 over 1. This is really 1/6x. Depends on how you write it. See over here, this was 2/9 x. I could rewrite this as 1/6 x equals 23. That's the same thing there. So I'd multiply both sides by 6 in order to eliminate the 6 there. And 23 times 6 is 138, and that's what x equals there. Over here on this one, to get rid of that minus 139, I would add 139 to both sides and solve that out there. So I'll let you do those. I did the one for you, but these are pretty straightforward. That's it for today. Have a great day, and we'll see you next time.